Well, hi, good morning. Thank you for joining me in my shop. Today is the last day of 2023. It's December 31st. Another day of sort of non-winter weather here. It's just, there's a dusting of snow, but the temperature's right around zero. Really, it's been one of the warmest and non-eventful, snow-wise, winters I've experienced so far in my life. Okay, enough on the weather. So what do we have left here to do? We've got this capacitor, which I've tried to identify some time ago, and I did not post any video about my machinations, so I'm going to make another attempt at trying to figure out what this guy is. Sounds like an easy thing to do. For some reason it's not. And then we have this great big honker up here, electrolytic capacitor. We need to identify where that is on the schematic, change that one out, experiment a little bit with it. So let's start with this one down here. What are you doing? Okay, so it's not going to answer me with words. I'm going to have to figure it out. It's attached to this terminal. This terminal has a resistor on it, has a wire on it over to here, has another capacitor coming up this way to a resistor, and I've replaced this one. I do not think it's grounded. Okay, so we look at this side. This is the one that has the wire coming off of it. The wire travels up, gets to the tone control. Okay, let us let's start here. Now the tone control wiper blade, if you like, is soldered to the chassis. I remember seeing that on the schematic too. So let's, and I've replaced this capacitor coming up to this side. It's the other side. No question about it. Okay, let's look at the schematic. We're going to start up here and try to find this wire and trace this wire back to this capacitor. That sounds easy. It sounds easy. Okay, here we go. Okie dokie. So we're dealing with the tone control. Here it is. We are looking in one direction to a capacitor. You know what? This is going to be it here. This is it. This has to be it. This must be it. I did this one yesterday. This has to be it. 0.005. Suddenly it's all become easy. Okay, let's go back. We'll cut it out and see what size it is. Goodness knows what I was doing before, but okay, I'm going to cut this guy out. I'm just going to stick a clip lead here so I don't forget. Is it a 0.005? Can't see it like that. Let's put the close-up camera on the job here and see what we can see. There it is, 005. Okay, I don't know why this was such a mystery, but I burned up a lot of time trying to sort out where this was on the schematic. Good thing I stopped and waited for another day like today. Okay, and we're just going to install a 0.00. No, we're going to experiment there. We are going to do some experiments. Okay. So, now this is the way it should go. straightforward. So 0.0000005. That would be this setting here. So we've got it set to the size. I'm going to test that capacitor, even though it's pretty obvious what condition it's going to be in, because every capacitor in this radio has done poorly on this test. And not that we expect them to do well, but different radios are in different degrees of degradation when it comes to these capacitors. The odd radio, maybe from the 50s, these capacitors will actually test not bad, like good enough. Not perfect, I suppose, but okay, there we go. I'm going to watch the eye now. The eye pi, what does it do? Oh my gosh, look at that, it opened right up. Okay, let's jack up the voltage here. It's 150 volts. Okay, now it won't open. So look great at 50. Interesting. You'd think it would open a little bit on 152, but no. Okay, not as bad as most of them in the radio, but still bad. Certainly. Put them in the pile. Okay, so I'm going to, oh no, we're not going to install the new one, we're going to experiment here. Jim, come on. This is what the whole thing's about. Oh, collapsing tripod. One of my leg clamps is a little weak on that tripod. It likes to give up the ghost at some point. Okay, so we are 0.005. We're connected correctly. We're ready to go. There we go. Ooh, antenna. I'll be right back. There we go.
Traffic and weather together on the one. Northbound route. Thanks, Jasmine. This report brought to you by Hakeem Optical. From Good News, southbound 400 approaching Shepherd. And they're cleared out of the way. We did have 3 left lanes.
What's this capacitor doing? I didn't really think about it. It's in the feed to the tone control. Bigger. Trying to improve the traffic with this. Don't hear a difference. We'll go smaller now. Smaller. Really small. Just going to the tone control. And we've got tone control set towards treble. Let's set it towards bass. Proper size. Bigger.
Fairly light at Pearson, just 7 kilometers per day and tonight, and then as we fall and get to our low near
smaller.
6 tonight, it'll feel more like 10 to 15 below. So factor that into your wardrobe selection for tonight. We do start the new year on Monday. For today, though, it is cloudy. We're currently at 0 at Pearson.
Midway.
Guaranteed high of +1.
And coming up at 10:30, we'll have the latest on New Year's celebration.
Base is gone.
Across the city. From what's open, closed, and how to get around tonight, keep listening for all the details. City News Time 10:23.
Need to make more money? Own a franchise and control your future. Come to the Franchise Show, January 13th and 14th at the Metro Toronto Convention Center to meet with the hottest franchises. Get valuable advice and free seminars and learn how you can open a successful business. This is your only chance to see all your best money-making opportunities in one place. Find
Trouble.
the business for you at Canada's largest franchise show, presented by Fat Bastard Burrito, January 13th and 14th.
Base.
Toronto Franchise
bass and treble range.
Our team of meteorologists works 24/7 to keep you informed on air and online at citynews.ca.
Range is gone.
What you need to know, it's the City News 680 Extreme Weather Center.
Brought to you by your Ontario Subaru dealer.
Stay with City News. Everywhere.
City News on 1024, bringing the new year with the polar plunge in Oakville. We are set to hit the frigid waters of Lake Ontario for the 39th anniversary of the polar bear dip at Coronation Park tomorrow. Organizers tell City News 680 the event raises money for World Fish in Canada.
One of the projects this year is going to Zambia, and they do not have access to fresh water. This shop that we raised over $2.2 million. It's gone a lot of that money goes a long way to helping millions of people get access to free, not just fresh water, but also.
Let's take a look at the schematic again here.
The Toronto Polar Bear Club will also host their annual
So it's this capacitor here, and I'm making it much larger. It's comparable to just connecting this wire to here in terms of signal. It's much larger, and we don't get a lot of bass. I got it backwards now. Look, I think maybe simply the way to look at this is it's the input to the tone control, and it's kind of establishing the say rollover point, could I say that, of the tone control. And as I'm changing this value, the rollover point is moving. That's me moving it with my mouse there. So they've picked a size which gives a very nice rollover point. It's in conjunction with this resistor. A 1 meg resistor here. 1 meg. So you change the size of this, you'd want to change the size of that to get the same effect. But then you might not get the range of motion here in the control. So all the action occurs right at the end of the control instead of across the whole thing. That's my thinking on it. I'm going to put in exactly the same size, 0.005. What about the leak? So not a lot of leak here, but any amount of leak would do what? So we're talking about a DC leak. So you are on the plate here. You have a high voltage here. A high voltage is, the DC part's blocked by this guy, so you would leak through here to ground. So you could get a leak off the plate circuit through here. If this got really egregious and leaked enough current, which I don't know how realistic that is. You start heating this guy up, depending upon where you had him set. So if you set him at the high end here, just a little wee bit of resistance, you could get a circumstance where it would smoke. I think if this were shorted, I think you could smoke this. I think. You know, it's the kind of thing you can't really know about till it happens, and I'm not going to make it happen. In the worst case, you have no tone control. Like if this were just open, then you just have no tone control, I believe. I believe you would get anything happening here at all. Okay, I'm going to change that with a 0.05. There's no reason to dwell on this any longer. Okay, that's done. Now the next one is this guy here. I think I know where that's connected, but let's just double check. So one end is going to the chassis, the other end marked positive is going to a terminal on this tube. This tube is the SK7 tube in between the two IF cans, and it's on pin number what? Pin number that's pin 1 there. So 8, 7, pin number 6. Pin number 6, that's often a plate pin on these radios. Pin number 6, eh? Let's take a look on the schematic. So we're talking about this tube, and pin number 6 would be here. It's a screen. And we follow this. I think I did this already. Okay, we'll go this way. Come up here. And we meet up with a 10 right here. That's got to be it. And it's paralleled by a 0.1 and a 0.1. Now the mystery is, where are these two capacitors? I have not come across them. Unless I changed them earlier and have kind of forgotten about it. But there certainly isn't one installed in parallel like you see it here on the schematic. This one, I don't know where this is. Okay, so 10 here, and what's it doing? It's really trying to hold the potential of the screens steady. So there's no variation in the screen potential, no signal affecting it. Okay. Great. I guess that effect, you could show that capacitor here. The 10 could be here. It would look more like it's controlling this whole line. So screen. It's just what it's doing. Oops. And screen again. So this guy is more or less supporting, if you can put it that way, the screen circuit for all three tubes. That's typical. That's a large capacitor, 10. Okay, now what if this guy's bad? What if I cut him right out? Cut him right out, he's gone. I think what you would have is you'd have a very significant drop in the output of the radio, loss of volume. And I also think you could start getting oscillations as the signal that's arriving at this tube, for instance, will end up on the screen circuit. The screen is like a mini plate, like a lousy plate in some respects. So some current's going to start flowing here. That current is going to affect the voltage of this screen, which is then going to affect the output, which is going to come back over here, and you're going to get an oscillation. And likewise, same thing would happen here, back to here, or here, back to here. You could have three different sort of oscillating circuits here going. Wow, that would be pretty interesting. But I don't have the capability to properly experiment safely with different sizes of this guy, because of that other decade box I tried to fix and couldn't. It'd be really useful for this kind of experiment, but I couldn't get the box to work, so we can't really experiment with this. So the most I could do is cut it out, turn the set on, and see what happens. Is there a risk? Does that risk something? I don't think so offhand. I think it risks really horrendous operation of the radio, but I don't think it risks any components. I don't think it causes anything to really go haywire. So we could give this a go and see what happens. We just cut it out and try again. Now, if these two capacitors exist, then there still is some capacitive effect on this circuit, but these are very small compared to this guy, if they exist. What to do here? Okay, so before I make a big decision, I usually go and drink some coffee. I think that's what I'm going to do. Drink a little coffee. Okay, the coffee cup says go ahead with the experiment. So we're going to. So first I'm going to operate the radio, because I did make a change and haven't operated it since. And we'll just make sure that it works. Okay, volume down. Plug is out. Is in. Away we go. So my simple rule of thumb with capacitors is the bigger the capacitor, the bigger the job, the bigger the difference it's making. Of course, that's just a kind of a dumb rule. There's no reason to think that's true in any particular case. But generally, I think that is true. So we're going to cut a big honker out of this radio, and I bet it's going to have a big effect. So first, we're operating the radio only on 82 volts. 82, that's pretty low. Surprising it works at all. Tone check. Perfect.
Semiconductors having 105% improvement on a sub-industry level within the S&P 1500. You would stick with that group, but you might, instead of looking at NVIDIA...
Oh, I have to check my stocks. Like I have stocks. Only a small percentage of the Canadian, or I think American population actually holds significant stocks. Like a very small percentage. So, mostly when you hear news about stocks, it's nothing to do with us. Okay, I'm going to cut it out. I'm going to cut it out via the ungrounded end. Okay. And I can test this. Wow. I can't really test this capacitor. I could. I can't. I can test it with this. Okay, any voltage left on it? I don't want to blow my little meter there. So, let's test for the voltage. That's the way to be sure. I was going to put a short on that capacitor, but you know, the way to be sure. Rule of thumb on charging capacitors. Charge them up for 5 minutes, discharge them for 5 minutes. I don't really, you know, hitting them with a clip leading, getting the spark maybe off a big capacitor, doesn't mean you've got rid of all the charge. We always think of the charge as being on the metal plates, but to a large degree the charge is being held in the material in between the plates. You know, that stuff. And it takes time for that charge to appear on the plates. Now, I could be totally wrong in what I just said. I can be totally wrong in everything I say and think. Okay, so what am I doing? What am I doing? I'm looking for voltage. Okay, there won't be any voltage on this thing. Here we go. Well, I think that qualifies as nothing. Of course. The old capacitor like that probably internally leaks out its charge pretty quick, especially a big electrolytic one. Let's get them out of there. Oh, no, we're going to operate the radio. I'm going to leave it right there, because I can always click it back in if I want with a clip lead. I want to experiment. Okay, volume down, because we don't know what's going to happen here. Just up a little bit. Tone in the middle doesn't really matter. Okay, so and we're doing it with the dim bulbs. If for some reason the thing draws extraordinary power, the dim bulbs won't protect it, but that won't happen. I think all that's going to happen, low or no output and lots of screaming sounds. That's my guess. Here we go. We're going. We're doing it. Oh, hand upon the power switch. Nothing so far.
Quiet on our major routes, including the 401.
It works without it.
The 404 DVP, the Gardner, if you're heading into or out of downtown, a very smooth sort of the Q. Mississauga, Oakville, and Burlington. I'm not aware of any other issues along the 403 or the 410. Off our major routes, though, we still do have some issues, including in Mississauga, Eglinton closed both ways, Dixie to just west of Dixie for police investigations. And at last check, we still had Wellesley closed both ways, Young to Jarvis, for a collision. It's time to Toyota at dawn. Toyota, the 2024 Grand Highlander and Grand Highlander Hybrid are available to test.
Yeah, how many parts can you cut out of this radio and still have it operate? I'm stunned that there was no noticeable effect from having that capacitor removed. That has floored me. Okay, let's pull this plug out of here before I make a mistake. Cut them out. Unbelievable. Unbelievable. Especially with my rule of thumb there, just flopped. Big capacitor, doing nothing. I'm floored. This is pretty well sealed on the ends. Interesting. First it says C, indicating it thinks it's a capacitor, and then it decides it's a rec. Okay, well, I don't think the makers of this really envisioned this instrument being used on capacitors like that. Not that that has an influence on things, it's just an interesting thing to think of. And now I thought of it. Okay, what we'll do is we're going to try to read the capacitance on here. So this is a 10, right? 10. So it's between a 0.1. My dial's off a bit. 0.1. I think it's on this scale. We got to get this right. So the center lead is the positive lead when you're doing electrolytic. Oh yeah, electrolytic. Got to flip this too. So the power, they call it a power factor adjustment. Okay, let's see. So if it is a 10, the 10 looks like the 10 is right here. Watching the eye now. The eye is opening way down here. Towards the end here, you can't really trust this. I'm going to set this to a smaller range. Smaller yet. Oh, yeah, smallest range. Okay, we'll go to the highest range. This is 20 to 1,000 microfarads. And the eye is not reacting at all. Back to here. This is 0.1 to 50, so this is the right scale, and it should be popping open here. Instead it pops open down here, but this doesn't mean much when you get right down towards the bottom. Let me turn off the power factor, or set this to off. Now this I don't know if that makes any difference at all. Not really. So I don't normally test electrolytic capacitors. You can see even changing scales doesn't affect the eye. So it's a baloney reading down here. Well, it just won't open. It won't open. So we got one device saying it's defective and the other device unable to test it. Let's put this on R. R times 100. We'll try to read this as a resistor. Okay, so it's right up towards the end of the scale. So again, it's probably not realistic. What if I disconnect? It makes no difference on the eye. I know it's hard to see the eye in the camera, but well, I don't know what to conclude. This thing failed every test, every way I did it. And you take it out of the radio, you don't even know it's gone. Now the question is, should I put one in there? The radio works without it. Of course I should put one in there. It's very, very important to control the screen circuit. Now, maybe there's a couple other 0.1s in here, and maybe they're ones I changed and didn't realize it. I don't remember that. I don't think that's the case. I think I've encountered this once or twice, looking at the schematic and not being able to find these 0.1s. But if they were in there, maybe they're enough to kind of keep the radio operating. And if I could find them and cut them out, if they exist, then maybe the radio would do all those weird things I was predicting. Maybe not. Okay, I will put a replacement in there. What is the rating on this? Now, this is a screen circuit, so high voltage there. This particular one, 450 volts. Very high rated. Made in Canada. I'm a little surprised at how this has come out. Okay, don't know what else to do with it. I'll put in the new one. Okay, I'm back at the tester with the potential replacement capacitor. Now I'm out of 10s. This is an 8.2. surely to goodness that's going to work well enough. So we're going to hook this up, get the polarity correct. I guess the polarity doesn't matter much on the, like I'm going to try to read the capacity. It should be 8.2. So on this setting, 8.2 is right about here. Right there. Kind of hard again for you to see the eye, but you can see it. So I stop right there, get down here and look, and that would be on this machine, that would be 6.5 is what it's reading. So to some degree I'm calibrating the tester. Okay, I'm going to test it on the other tester too. It's kind of a way to basically keep me honest here. Maybe this is out of the range of what this guy can do. I don't think so. What does he say? It's a capacitor. Okay, so he says it's 7,500 nanofarads, which would be 7.5 microfarads, which is a little less than what it says. It's got V loss and this other ESR number, which I never pay attention to. Well, that's interesting. Both testers indicate this is less than its rated amount of 8.2. 10, 7, nothing, and the radio works. I'm going to put this in. Okay, he's going in. Okay, I've installed that little capacitor here. Picked a different ground point. And yeah, it's in there good. Okay, we're going to operate the radio one more time, and then that's going to be it for today. Tomorrow, I hate to say it, it will be string day for this radio, and I will attempt to put a string on it. That can be a very uncomfortable experience. I don't think I have a string diagram. At least I haven't really looked hard for one yet for this radio. But hopefully I can find one. These radios are tricky at best, even with a string diagram to do the to put a string on. Without a diagram, yay. This one looks pretty simple. This one looks very simple, in fact, but you know, there's still probably a couple ways to get it wrong, and I will find them. Beautiful.
Convicted drunk drivers will be stopped at the U.S. border. Change the conversation. Sponsored by the Brewers Association of Canada. It is time 11:18. Israeli Prime Minister Benjamin Netanyahu says the war against in the number of colds and flus that I got when I started.
So I'm pretty, I can't be sure, but I'm pretty sure this is 8:20 from Hamilton, Ontario. It's a comedy channel. They're always playing comedy records. So that's with only 81 volts on it. She's working good. So tomorrow the string. Thanks a lot for watching, and hope you're getting a kick out of my little experiments here. The surprising results are really quite eye-opening and leaving me scratching my head a lot. So hopefully it's doing the same for you. See you tomorrow. See you next year.